Welcome back to the Hunger for Change podcast, where we challenge the status quo and share insights from the brightest minds in health and science. I'm your host, Niklas Gustafson, and today we're thrilled to have Dr. Tommy Wood with us. Tommy isn't your average researcher. He's a neuroscientist who loves to nerd out at the highest level, and he's also a trusted advisor to world-class athletes across numerous sports. Tommy has an impressive background with degrees from top universities: biochemistry at Cambridge, medicine at Oxford, and a Ph.D. in physiology and neuroscience in Oslo. Nowadays, he's making waves at the University of Washington and the Institute for Human and Machine Cognition, focusing on brain health and injury treatment. Tom is passionate about making science accessible, whether that's through his role at the Wiley Journal Lifestyle Medicine, guiding the British Society for Lifestyle Medicine, or advising health tech companies. He's on a mission to show us how lifestyle and environment shape our health and how we can live longer, better lives. Get ready for a conversation that will enlighten, inspire, and maybe even challenge the way you think about your health. So let's welcome Dr. Tommy Wood. Thank you so much for being with us today.
Thanks so much for having me. I'm really excited to join you.
I'm very excited. First of all, what does health mean to you, Tommy?
That's a great question to get started with, and not always an easy one to answer. But I think that the simplest way that I think about health is that health is having a brain and body that does what you want it to do when you want it to do it. And that can be everything from physical pursuits, cognitive pursuits, being able to socialize and interact with your family and having good mental well-being at the same time. So that's how I think about health, is just being able to do what you want to do when you want to do it.
Right. Yeah. Having the freedom, right, to do whatever you want to do. Could you talk a little about your background? How did it all start?
You've sort of listed my CV at the beginning, which I guess is part of it. In reality, I have these sort of two tracks that have gone throughout my career. So I first trained in biochemistry and then went to medical school and worked as a doctor in London for a few years before doing my PhD. And my academic track is very much in basic neuroscience. I run a basic neuroscience lab. We have students and we look at ways to treat the injured brain. A lot of that is in newborn brain injury, but also traumatic brain injury and concussions. And we're increasingly looking at late life cognitive function as well, like dementia risk. But throughout that kind of trajectory, I also became very interested in how we can both holistically support health, but how that also applies to elite or top level athletic performance, or any athletic performance. Anybody who wants to perform better at a given sport. So as an undergrad and then in medical school, I was a rower. I coached rowing. I was head coach of our medical school boat club for a couple of years. And during my PhD, I also then, on the side of my work, I started a blog and podcast and looking at all these different ways that we can support health and performance. And I helped build a company where we worked with athletes to try and keep them in the game as long as possible. Some of them just wanted to have longevity in their athletic careers. Others were maybe struggling with some health issues alongside their athletic performance. So we were looking at ways that we could help support them in that. And now those two tracks kind of come together. So, I look at how do we support brain health across the entire lifespan, from both a health and a performance perspective, kind of bringing in aspects of the basic neuroscience, the work we do in the lab, as well as some of this more applied stuff, working with athletes and individuals to try and optimize. Optimize isn't my favorite word, but try and improve their health and performance.
Yeah, very interesting. So if we jump right into human metabolism, how has the general view of calories in, calories out, how has that model changed? Is this model still relevant?
Yes, I think it is, and it's funny because anybody who's really interested in this topic will essentially have seen these two warring models, for want of a better word, and they are the energy model, right? So calories in, calories out, and then there's sort of the maybe the most popular current alternative, which is the carbohydrate insulin model. So that the insulinogenic calories you consume then drive fat accretion, or the fat that you eat alongside those that gets stored, and then that creates this relative energy deficiency that the brain sort of measures, and then that drives hunger. It's sort of almost the opposite way around. Yeah. However, I think in reality, the sort of the argument that happens between these two models isn't really helping anybody. It's very academic, and people are, you have the academics on both sides slinging mud at each other, and they write a paper and then a response to a paper. And if you watch it from afar, the interesting thing is actually these models are getting closer and closer together, right? Because they say two things broadly, and it's common across both of them. One is that, say, weight gain is caused by consuming calories in excess of your requirements. What drives that consumption is under debate by the models, but you have to eat more calories than you're burning, like to gain weight. And I think both models would agree with that. And then you also acknowledge, and both models acknowledge, that what you eat changes your hunger and changes how you distribute and use the calories that you consume, right? So calories matter, but then the type of food also matters. And both models agree with that. Yeah. And everything else, I think, is interesting academic detail. And right, we want, people want to get into the mechanism. They want to understand what drives hunger and weight gain or body composition change. And there is space for that. But when it comes to the individual who wants to try and change their body composition, none of that is particularly helpful. And it's very clear when you read some of these papers that these individuals who are writing them have never actually helped somebody who wants to try and improve their body composition, because that process of coaching and finding sustainable dietary change that works for the individual, that supports them in the way that they want to be supported, the models don't matter. What matters actually is how you help that person change their body composition. So I think that we've there are still arguments about what causes weight gain and what's driving it, but I think the core things are, how do you match your caloric intake to caloric requirements, and how does the food that you eat change that? And everybody agrees on that. It's just how the different parts fit together is, there's still some things to be fleshed out.
I think what happened maybe like 10, 15, 20 years ago, people didn't take people were just like counting calories in a way that they were not keeping in mind what type of food they ate. So I think that changed during over the last 10 years, at least what I've read and what I follow, even on social media. Now people are taking more in account what type of food you eat. And also I think that is something that has to do with metabolic flexibility, because what we see in our modern society is that people, they are not metabolic flexible as we were 100 years ago, when we could switch from carbs to fats and back from fats to carbs. What would you say? Because people are not just eating more carbs today, we are snacking all day. We're eating all day long. How do you see that? Is that a problem?
In its current format, yes, absolutely. We know that, two things: that the majority of individuals continue to, gain weight over time, and also the metabolic health of the population has, even if it's not getting worse now, it's certainly declined such that the majority of the population are not in good metabolic health, and a lot of that is driven by diet and physical activity and some other lifestyle factors as well, but those obviously play a big role. There's a nice quote from Sachin Panda, who's very big in a lot of the circadian biology of eating. And when he's looked at individuals and sort of the timing of their meals, he basically says that when our eyes are open, our mouths are open, which basically means that we eat from the minute we wake up to the minute we go to bed. And But some people do need to do that, right? I've worked with athletes where you have to decrease food quality to increase calorie consumption such that they're able to support the work that they're doing, right? So for some
Mm.
people, you just need to get in as many calories as you can. But that's not the case for the majority of us. And
No.
especially then, if the foods that we're eating are driving overconsumption, which really seems to be the case for a lot of the food we're eating.
Mm.
And you're right, human physiology is incredibly adaptable, but we have to use that adaptability if we want to have it. So we have to be able to not eat occasionally, and we should be able to survive on a wide variety of macronutrient,
Right.
ratios and combinations and
Mm.
amounts. We just don't do that because we just have this, broadly at the population level, we have this very consistent high carb, high fat, low
Yeah.
protein diet that doesn't allow us the opportunity to be flexible. And
To be
we
flexible.
also don't move enough because physical activity is another big part of driving and maintaining metabolic flexibility,
Right.
which again isn't probably happening as much as it should.
So, how do factors like food's texture, flavor, and how it's prepared affect our feelings of fullness and nutrient absorption?
Yeah, there's a few bits that go into it, and it is really important. A lot of people would originally think about uh, fiber content, water content, and then protein content as well, because the more you have of each of those in general, the more satiated you feel
Yeah.
with a given meal. But there's been some interesting recent studies looking at food texture, like you say. So things that are crunchy and hard to eat also increase satiety compared to very soft foods. So you imagine the kind of difference between a milkshake, which is very calorically dense and soft, and you could throw back 2,000
Yeah.
calories of that, no
Yeah.
problem. Whereas if you wanted to eat 2,000 calories of a steak salad with some like crunchy fresh vegetables and stuff, that's gonna be very hard. So that all of those things come together. So I think protein, fiber, water,
Yeah.
and texture, like so that kind of crunch and the amount you have to chew it,
Hmm.
all those things sort of increase the likelihood that you'll feel satiated after a meal.
Right. So you mentioned protein, and what about fats?
So fat itself is not particularly satiating. That doesn't mean that it can't make up a majority of your calories, because there are a lot of people where it does, and that's great. There's probably some combination of when you have salt and fat and some kind of carbohydrate or sweetness, that really seems to drive consumption. And so it's probably it's the combination of multiple macronutrients as well as some of the flavorings that then can
Mm.
drive overeating. So you think about chips and cookies and sweets and these things, and they have this kind of optimal combination of a
Yeah.
little bit of sweet, a little bit of salt,
Drives
high
hunger.
fat, high carbohydrate, and
Mm.
that sort of combination seems to be really good at making us eat a lot of it.
Consume
But
more.
if you tested just like pure fat, it's not particularly satiating. But also, it probably needs to be combined with other things in order to drive overconsumption, for one of a
Yeah.
better.
Tommy, could you share your perspective on the main factors contributing to the rise of insulin resistance within the population?
There's like a framework in my head of the things that are necessary for overall health, and these kind of fit in there as well, and they'll differ in different amounts for different people, right? So nothing here is going to be surprise. It's going to be diet quality, it's going to be physical activity, it's going to be sleep and circadian rhythm.
Mm.
Then how stresses are handled, like chronic either social stresses or psychological stresses. And then the social connection plays a really important role as well. And so I think each of those can contribute in one way or another. Like, we know that if you're chronically socially isolated or socially stressed, that activates this evolutionary survival mechanism, which is associated with higher levels of inflammation, higher sympathetic nervous system activation. And if you activate that long term, that can certainly contribute to things
Mm.
like insulin resistance and chronic disease. But equally, I think probably the most important things are our diet quality and volume, or how much we're consuming, as well as relative levels of physical activity. And
Yeah.
it's funny because there are two different papers that kind of say the same thing about those two aspects. So one is, there was this nice paper that Inigo San Milan just published about the importance of mitochondrial function in health in general, which is obviously a mitochondrial function is essentially directly related to metabolic health. And he makes the good point that historically, as a species, we were incredibly active. We moved all day, every day.
Yeah.
But it's essential for our biology to function that we move frequently and in high amounts.
And also being outside, right? That's
Yeah,
also,
yeah,
yeah.
absolutely. But we've engineered this out of our environment. So now
Yeah.
exercise is an intervention rather than being this thing that's like critically important for our
Exactly.
health. And Charles Brenner wrote something similar about fasting. And
Mm.
fasting isn't magic, but in a society where we no longer experience changes in food availability, which again were just sort of like baked into our physiology,
Yeah.
then fasting and diets become an intervention, because we've just lost that connection to the food that we evolved to eat. So we've kind of changed the environment such that these core requirements of our health, we have to kind of add them back in as interventions rather than them just being
Yeah.
part of everyday life as they should be.
So, what about obesity when it comes to genetics? Would you say is obesity genetic? I mean, it's part of our genetics, because that's something that I see recently a lot on social media. People debating if it's, yeah, you are obese because it's part of your genetics. What is your view on that?
There is clearly a genetic component to our body mass and body composition, but it's also very clearly an interaction between our genetics and the environment. So when you look at, they've done these big studies and they develop these polygenic risk scores where you look across hundreds of genes and polymorphisms and how they affect body weight. And you can see that with a large polygenic risk model, you can predict about 13% of somebody's body weight. I think they used BMI in this study. So
Mm.
it's not nothing, but it's not the majority of what's determining somebody's body weight or body composition. The fact that obesity is just purely genetically driven has been, I think, has been massively oversold. But if you put humans in the current modern environment, yes, different people will respond differently to that based on their genetics.
Mm.
However, if you removed all those people from the current modern environment, I think we wouldn't see the issues with excess adiposity and inappropriately low muscle mass. I think low muscle mass is another really important component. So yes, there's a genetic aspect, but it's really driven by the environment. It's genes determining some aspect of how we respond to the modern
Yeah. Yeah.
food, in particular environment. But it doesn't matter what your genetics are, because you can fix the food environment and then the genes matter much less. Like, I think that's the takeaway, right? If
Right.
everybody's going
Yeah.
to just eat the same modern westernized diet, then yes, genetics do absolutely matter. But the alternative way to think about it could be to say, well, how about we just don't eat like that? If we can, that would be ideal.
Mm.
Like,
Mm.
and then I think genetics are going to matter much less.
So, if we take a look at the fat consumption in today's society, I mean, from an evolutionary perspective, how do you interpret the difference in fat consumption between ancient hunter-gatherer societies and today's standard diets?
When we go, if you look at hunter-gatherer or sort of indigenous, more ancestral diets, and some of which still exist today, the most important thing you can say is that they were hugely variable, and they still are. So you have those who argue that early on in human evolution, we ate what they call the megafauna, so like the massive woolly mammoths, and they had a very high fat content, and we primarily ate protein and fat. However, we know that there are groups that survive all around the world where the majority of their protein is very lean, because that's the access that, those are the animals that they hunt, and they consume a large amount of carbohydrates. So there are and have been groups that ate a much higher fat content than sort of the average Western diet now. However, there were also those who ate much less fat, just because of the nature of what's around them. And this probably differed by latitude. So
Yeah.
you and I, our ancestors probably ate a lot more protein and fat up in the north, in the Nordic countries,
Right. Yeah.
compared to somebody whose ancestors lived close to the equator, where the protein is probably leaner and they have a higher access to carbohydrates. So it really just depends on where you are in the world. And there are some studies that show that hunter-gatherers, based on latitude, their ratio of carbohydrates to fat changed. The more north you go, carbohydrates go down and fat go up. And so I think this just tells us that humans should be very adaptable. And we are very adaptable. We just don't really express that as much as maybe we should.
A huge difference probably also is that we consume refined oils compared to like 10,000 years ago. The fats that we had were all animal fats, or most of the fats that we had were animal fats, right?
It again depends on where you are. If you're close to the equator and you have various where they still eat and have eaten various nuts and legumes, obviously you get more of those plant-based fats that are maybe more similar to what's seen in some vegetable or plant oils. But yes, again, in a lot of regions, the vast majority of fat consumed is either from seafood or from land game.
So we at home we have a 4-month-old girl, and this makes me worry about the formula, the baby formula. Still, she's being breastfed, but the day that she won't have the ability to get the breastfed, then we need to think about how to replace it, right? And the thing is that baby formulas, as far as I know, most of them are on the market. They are full of seed oils. Normally, it's the base is seed oils. What is your view on these baby formulas? Because I mean, the omega-3 is such an important part of the milk they get from the mother, right? And the DHA, EPA, that is very important for the evolution of the brain.
So over time, formula has actually improved dramatically compared to maybe what was done 30, 40 years ago. We know that what the baby consumes in the first few months after birth, and even longer after that, changes the composition of the brain. So there have been some studies where they actually looked at the fatty acid composition of the brain in infants who died for some reason not related to the brain. So their brains were normal, and they looked at what they were consuming. And so historically, there was some very high, primarily linoleic acid, soybean oil based formulas, and compared to babies who are breastfed or who have more omega-3s in the diet, you can see those shifts. It's actually changing the composition of the brain because the brain is primarily fat, and most of that comes either from the mother during pregnancy and then the diet. So DHA we know is critical to brain development. Oleic acid, which is obviously found very widely in animal fat, but also in things like olive oil, that is also a major component of brain fats. So the fats that you consume in that period are very important. Formula over time has increased omega-3s. It has decreased sort of these soybean and linoleic acid, very heavy fats, and has also increased medium chain triglycerides. Medium chain triglycerides are produced by the breast tissue to be expressed into the milk, and they are converted into ketones in the developing body, which then are primarily used by the brain as precursors to make cholesterol and things like that. So if a baby is fed formula, there can always be improvements, but it's not necessarily a bad thing. Like, formula is much better than it used to be.
They're better today than they were.
Yeah, much better.
So what about cholesterol? We have been forced to believe that cholesterol is the enemy. one of the worst enemies, like for our health. Why is this problematic, would you say?
It's a very, it's a nuanced picture that requires thinking about it from multiple directions. So the reason why people are focused on cholesterol is generally LDL cholesterol, and more appropriately, if we're thinking about risk factors, ApoB containing lipoproteins as risk factors for cardiovascular disease. At the population level, ApoB levels absolutely correlate with heart disease risk. It's a very strong risk factor. Then when you lower that with medications or with lifestyle, cardiovascular risk decreases. Like,
Yeah.
it's very clear across very large studies. So it is important. However, we have to acknowledge the fact that that information comes on the background of this population that we're talking about earlier, eating a Western diet, largely physically inactive, poor metabolic health. And there are an increasing number of studies, and several studies going back even to some of the original statin trials, that show that if you're in good metabolic health, your cholesterol or ApoB level matters less in terms of your cardiovascular risk. It doesn't mean it doesn't matter at all.
But other biomarkers matter a lot.
Yeah, exactly. So we just have to say that there are these other aspects of health that modulate how important cholesterol levels are. And I think that that's kind of being lost in the noise right now. Like, some people are saying, well, because metabolic health is so important, cholesterol doesn't matter at all. I don't think that's true. We're still figuring that out. And there are other people who say cholesterol is so important that nothing else matters. And that's also not true. So the answer is kind of somewhere in the middle. And we know that, cholesterol is incredibly important for, the structure of cells. We need, like, particularly the structure of the brain. The brain makes its own cholesterol. So there's kind of this theoretical possibility that if we, overly suppress cholesterol production, particularly in the brain, that can then affect long-term cognitive function. So we know it's important. Some people will say that it's the only thing. Some people will say it doesn't matter at all. I think the answer is somewhere in the middle. But we know that if we manage both metabolic health and then, in the right setting, if we have to manage cholesterol levels, we can dramatically improve cardiovascular disease risk. We just have to appreciate there's some nuance.
Also, it's complicated because you mentioned ApoB. Higher levels is more seen like as a risk factor, but if you are doing long-term or even short-term fasting, it's the ApoB levels, they go up, right? Which is not something, shouldn't be bad for you.
This kind of fits into this idea of something called the lipid energy model, which my colleague Dave Feldman kind of popularized, and we're doing I'm sort of peripherally involved in some studies looking at this. But essentially, there's this idea that when you become more on, you go into more of a low insulin, fat-based metabolism, you increase ApoB export production from the liver, because those are the particles that are transporting fats.
Exactly, transporting the energy in our body. Yeah.
And so you see that in people who are fit and healthy, who go on a ketogenic diet. But then you also see that with extended fasting. And it's funny because there are some people who, and in my mind, that makes perfect sense. If your body's, up-regulating the transporters for fat that you're using for energy around the body, it's not been proven, but it makes sense to me. So
it makes sense. Yeah. I experienced that myself, because when I started switching from more of a normal diet to a more carnivore diet, and even during a couple of years I did a ketogenic diet, I saw the ApoB going up. The LDL went up a lot. So and I agree with you. I suppose that's it sounds like a reasonable explanation that the body needs to transport the energy in our bloodstream, and the LDL is part of that explanation, right?
What you don't want is free fatty acids in large amounts in the blood. You want them attached to a carrier where they're sort of more safely stored, and the way that's done is first, so it's ApoB containing lipoproteins excreted from the liver, first on VLDLs that then become LDLs as triglycerides are taken off. And if that's making up the majority of your energy supply, then you need more particles to carry that. And this is also, it also feeds directly into how much carbohydrates we're eating, because both the production of ApoB in the liver and LDL and uptake from the circulation are determined by insulin. So it all fits
Yeah.
together, right?
Yeah.
You
Yeah.
decrease carbohydrate intake, insulin levels go down, you're then more fat-based, you increase production and decrease removal of these particles from the blood so that fat can be carried around. Again, it's not proven, but it all kind of makes sense
Makes
once
sense.
you
Yeah, it makes
understand
sense.
what's regulating what.
Totally. So, from a practical standpoint, how sustainable is long-term caloric restriction for an average person?
Yeah, so this kind of goes back to the beginning of this conversation where we were talking about these models of weight regulation. And in reality, it's eating a little bit less of what you're currently eating, and particularly if it's a diet that previously led you to overconsume, you're then trying to eat less of something that would otherwise drive you to overconsume, and you're going to be hungry and cranky, and so that's really hard. And so it's worth saying that it can be done, and people do it, of course, right? You do like the if it fits your macros or whatever, you just count everything, and a lot of people do just fine on that. But if you're not counting and you're not really, very cognizant of what you're consuming, it's very difficult. And so some people have looked at that and said, well, caloric restriction doesn't work because you regain the body weight. And that's only partly true. It does work. It's just really hard to keep doing it.
It's very hard. Yeah, yeah. So what is your advice to those, to people trying to do this?
The best thing that you can do, if you're able to, is go back to some of those ideas that we talked about earlier, right? How can you change your diet so that it's less calorie dense?
Yeah.
And ideally more nutrient dense, because most modern foods are very nutrient poor.
Yeah.
And then also increase satiety. So all those things that we talked about earlier are your friend. So higher in fiber, higher in water content, higher in protein content. Anything that's higher in nutrient content is probably going to help as well, because that does help regulate body weight. And then add some texture.
Helps with satiety, right?
And how you then do that can really change from person to person, right? And some people that might look a lot more whole food, plant-based, and a lot of people feel good eating that way. Not everybody does. And for other people, it might look more like a carnivore or a ketogenic diet. And then, there's right in the middle works as well, and then maybe we're thinking more like what people call a Mediterranean diet, which I don't think actually exists, but you know what I mean. Sort of there's a bit more of the healthy fats, and there's lean protein, and there's lots of vegetables, and that's great as well. But across all of those things, what you've done is you've decreased calorie density, you've increased the nutrient density, you've usually increased protein intake. Across all of those things, that's the way to do it. All those things will spontaneously help you decrease caloric intake rather than having to count it. And I've never counted a calorie in my life because I hate it. So you have to find other ways to kind of self-regulate.
Could you explain to us, to our listeners, what is autophagy and also mitophagy?
Autophagy is essentially the process of breaking down and recycling components of cells or entire cells. And mitophagy is just that process happening specifically to mitochondria. So as you try and maintain the function of a tissue, you're using proteins and things, they get damaged just like everything that we use in daily life, and then those need to be broken down and recycled. And that's what you're doing with autophagy.
Yeah. So what is the relationship between exercise, fasting, and autophagy?
There's been this long storyline related to fasting, which says that the more you fast, the more autophagy you upregulate, and that's because as your energy intake decreases or disappears, your body starts to scavenge the broken down things to try and
recycle,
and some of it gets burned for energy. And that is true, but in humans it probably takes a lot more fasting to upregulate autophagy than we've previously thought. It takes several days, probably 3+ days, before you start to see any meaningful amounts of autophagy. Where we study it mostly is we study it in mice. And in mice, fasting is an incredible energetic stressor. Like a mouse will usually die within 24 hours if it doesn't eat. A mouse can lose 20% or more of its body weight in a day if it doesn't eat. Right? Humans, if you
Wow.
don't eat for a day, you might lose like 1% of your body weight, if that. You actually don't lose that much at all. And so there's this discrepancy between where we're looking at autophagy, which is in mice, and
Yeah.
humans. And there's now more and more studies showing that when we fast in humans, we don't see nearly the same responses that we do in mice. And actually, a lot of what we thought about fasting
Mm.
doesn't do what we thought. And
Really?
yeah, there's a nice paper that a colleague of mine, Christy Sorosuk, recently published where they did a systematic review looking at mitochondrial biogenesis responses to fasting. And again, there's this idea that if you fast, you upregulate autophagy and you improve the function and number of your mitochondria so that you're more metabolically efficient. This is kind of the storyline that's sold to us in the
Right.
fasting literature. And it turns out it's actually not true.
So what you're saying is that you need a lot more. You need like 6, 7 days before you start this process.
Potentially. So this is not for autophagy, but this is for mitochondrial biogenesis. But it's kind of
Mm.
it kind of helps show
Yeah.
the difference between what we think is happening and what is actually happening. So when we study mice and rats, the majority of studies do show some of this PGC1 alpha mitochondrial biogenesis response, but not all of them. It's something between like half and 2/3. In humans, up to 3 days of fasting doesn't upregulate this process at all.
Mm.
So some of the things that we're told about fasting, because we saw it in a few mouse studies, doesn't happen in humans. Exercise is really good at upregulating autophagy in particular. And this has mainly been shown in muscle tissue because that's obviously what you can easily measure in humans. But there's also some data that shows that if you're upregulating autophagy through exercise in muscle tissue, you're also upregulating autophagy in other tissues at the same time. And this can happen in humans within like 30 minutes of aerobic
Mm.
exercise. There's a nice quote by Bill Lagarkos, which says that exercise is fasting and fast forward. And basically, all the benefits that we've been told that fasting
Mm.
has, which may take several days or may never actually happen in humans, even though they
Mhm.
happen in mice.
Yeah.
All those things happen when we exercise. And it doesn't take that much exercise to do it. So I think that if you're thinking about autophagy, you're thinking about mitochondrial biogenesis, you're thinking about metabolic
Yeah.
flexibility and
Yeah.
metabolic
Yeah.
health. I don't think fasting is the answer. I think exercise is the answer.
Okay.
We have
Okay.
much more.
That's so yeah, that's fascinating. So what kind of activities and intensity levels do you recommend?
Yeah. So where they've really looked at this is kind of standard aerobic exercise types. So 70% of VO2 max for sort of 30 to 60 minutes, which is basically like going for a jog or a cycle,
Yeah.
a cycle ride, something like that. So like some, what we might call zone two, that
Mm.
kind of like basic aerobic activity that you can do for a long period of time.
Between half an hour and 1 hour.
For some of these responses, it just seems to be determined by the combination of intensity and time, right? So if it's
Mm.
less intense, you need to do more time. But if it's very intense, you can still get some of these adaptations in short periods of time. So
Shorter. Yeah.
yeah, so I think that in general, the kind of the average recommendations are pretty good, which is that, 2, 3, 4 times a week, you should do some longer period of lower level aerobic activity, and
Mm.
then maybe once or twice a week you do something very intense, like you do some short sprints
Okay.
or something like that. Then you're sort of working both ends of the spectrum.
What advice do you have about meal timing when it comes to, I mean, in relation to workouts? Should you eat before? Should you eat after? Shouldn't you eat at all? Should you wait for a few hours?
This is something where people have kind of thought that you do fasted exercise, maybe you get some more of these autophagy and mitochondrial biogenesis responses and stuff. In reality, it seems like that's not the case. Like the major driver is of the adaptations is the exercise itself. It's possible that you could tweak some little things right at the pointiest tip of sort of performance, but for most people, I would eat in a way that makes you feel best when you exercise, such that you complete the exercise and you feel good doing it.
Mm.
And some people like to like exercise fasted. Some people like to have some food on board. I don't think it really matters that much.
I personally like to exercise without eating before, and then after, like a couple of hours after, that's when I'm like most I'm hungry after.
And that's fine. And
Yeah.
it's just that when you look at scientific research, yeah, the response to the exercise or how you perform in the exercise probably doesn't matter that much. Although
No.
actually, if you're doing very hard, intense aerobic exercise, having some food beforehand is probably going to help performance.
Yeah.
But that's not necessarily what you're
No.
exercising for, right? So you want to exercise when you feel good, and the way that makes you feel good, and then also supports other health aspects. And so for you, that's not eating beforehand. That's great.
Yeah.
But in terms of how you respond to that exercise, it probably doesn't really matter that much.
That's interesting. So beyond fasting and exercise, are there any other lifestyle factors that impact autophagy? If we go back to autophagy,
Anything that creates longer term shifts in inflammatory status or metabolic health, I think you start to see some of these other processes associated with aging, these hallmarks of aging, one of which is decreased proteostasis, or basically you don't have as much autophagy as you did before. That's part of it.
Mm-hmm.
And I think some of that can be driven by these other factors as well, right? We talked about the importance of sleep and stress and social connection, and those can certainly drive some of these other processes. So I think in terms of, if you want to stimulate autophagy right now, which a lot of people are interested in that, then I think exercise is the most important thing. But these other factors are going to play a role, and certainly for muscle tissue autophagy, there are other ways to stimulate that tissue. For instance, cold being one of them, because if you induce a shivering response, right, actually you are creating a metabolic stress in those muscles, and then it's the metabolic stress that drives the autophagy process. So there are some other lifestyle factors. So like maybe cold.
So cold plunging could be a good idea.
I think there's a lot less known about that, but certainly it would kind of make sense in that framework.
So if we take a look at the lactate during exercise, what are some common misconceptions regarding lactate during exercise, and how can we better understand its benefits?
This is interesting because lactate is kind of the boogeyman of high intensity and strenuous or anaerobic exercise for a long period of time. And we talk about lactic acid and that kind of acid, the burn of muscles when we do that kind of exercise. When we're producing lactate, actually what we're doing is we are net consuming protons, which are what generate acid. It's actually a way to help decrease the amount of acid in the muscle tissue. But of course, you get to the point where those things where still it is part of the problem is in this acidic process, but it's not the lactic. It's not the lactate that's the problem, right? You are generating excess protons, but lactate is actually helping you offload some of those. Lactate can also then is exported from the muscles, but it can be used in other tissues. So particularly the brain, and it may be having one of the reasons why exercise may be beneficial for cognitive function is actually lactate going to the brain, and it can change some gene expression. It can help produce some other factors that support the brain, like BDNF, and it's a metabolic substrate that can be used by the brain. However, it does also seem that you can get to a point where you have so much lactate that actually the brain interprets that as saying, I'm doing so much hard work now that I'm actually going to start shutting down a little bit because I just can't sustain this. So there's probably a sweet spot. Like some lactate seems to be beneficial, but you can get too much of a good thing. But
too much.
This idea that lactate itself is a problem is certainly not true. And lactate may be, like we said, neuroprotective. Some studies have used lactate as an energy source during exercise that may be ergogenic. So lots of potentially good things about lactate. We just have to separate it from the acid part.
So when you mention, when you push your limits in training, what are some key indicators that they might be exceeding their recovery capacity, and when it's not, and when it's basically not good for your health?
Are you Are you thinking like chronically over time?
Yeah, I'm thinking more like professional athletes that want to improve themselves. They want to get to next level, and during a longer time, if they do this, how could it be harmful to your health?
There was this really interesting paper that came out a few years ago in Cell Metabolism that showed that if you did a very high volume of very high intensity exercise, you could start to see decreases in metabolic health. Actually, these individuals became more insulin resistant just because of the volume of very strenuous work was actually having the opposite effect of what you think it might happen. So we know that very high volume, very intensity work can actually have negative effects on metabolic function and metabolic health, at least in the short term. You know, the sort of the guiding principle of all of this is that where you don't get stronger or fitter when you're exercising, you get stronger and fitter when you're recovering, right? So you need to generate enough of a stimulus to create the adaptation you want, but then you also need to have adequate recovery time afterwards. And there are a lot of bits that can go into this. So are you consuming enough of the right types of calories to support, you know, this level of output? And that's something that I've certainly seen a lot of athletes struggle with. They just can't consume enough food to sustain that level of exercise. And so a lot of it is then related to this like relative energy deficiency in sport, as they call it. So you're just not consuming enough calories to support all the processes your body needs in addition to the training. And then a whole bunch of things can be tracked or that you see come along with that. So often you'll see changes in mood. And there are questionnaires around relative energy deficiency in sport where you can sort of change, you can track differences in mood over time, and you see a deterioration, or you can see a deterioration in mental health. But then there are other things like heart rate variability is going to decline over time. Sleep may worsen. Which of these you track is going to be different for different people. So some athletes are very good at that. They know themselves and they can kind of feel, do you know what? I'm pushing myself too hard now. Some just want to be like pushing the limits all the time. And then you might have to use some objective markers like HRV or other things to kind of show them, hey, do you know what? You've gone past the point at which you're getting the adaptation that you want here. When you look at some large aggregated data, so Joel Jameson is this, you know, one of the guys in strength and conditioning. He's worked with primarily in fight sports, but he has this Morpheus platform where he's collected vast amounts of data. And I think that something that he's seen from those data is that the people who recover the best and seem to perform the best are those who only very intermittently do very high intensity exercise, and the rest is much more of the sort of the lower level type conditioning. Whereas those who are really pushing it, you know, all the time, and they're always doing very high intensity work, you know, that seems to be, you know, overall detrimental to various other factors like their heart rate variability. And the final piece of this relates to other aspects. So like injuries, and it's very common for amateur athletes to get injured because they're not listening to their body. They just think that I need to exercise really hard all the time. And actually professional athletes can be much better at regulating that. You know, they understand that they need to just train to get a specific adaptation, whereas often we're kind of sold that, you know, exercise has to be hard all the time, and so we go and do hard exercise all the time, and then
recovery is so important, right?
Exactly.
Yeah. Tommy, it's been really interesting talking to you. I think we will have to wrap this up. What are you working on now? Any future projects that you could reveal?
There are a few things that I'm working on right now that the people can go and find, and then as new projects come up, they'll be released through there. So a lot of my work in this space is based primarily around brain health and cognitive function and how we can improve that. And I do a lot of this work with a neurologist, Dr. Josh Turknett. So we have a podcast together, which is the Better Brain Fitness podcast. And it's question and answer. So if you have a question about brain health, you can put it in on the website, and we answer a question every week. And then related to that, we have a Substack, which is betterbrain.fitness. And if people sign up for that, then there's a download you can get, which is nutrients and diet approaches to optimizing brain health, and that includes like blood tests that you can measure.
That's great. And so where can people find you?
Yeah, so those
Apart
two places,
from these two,
and then Instagram at Dr.
Instagram,
Tommy Wood. Yeah, is the main place. I don't really play on Twitter very much, so Instagram is the best place.
Thank you so much, Tommy, for your time. It's been a pleasure.
Thanks so much for having me. This is a lot of fun. I really appreciate your time.
Thank you so much for listening to the Hunger for Change podcast. I hope you enjoyed the episode. I also wanted to take a moment to talk about Naturally, my brand of healthy food products. At Naturally, we are on a mission to change the world through what we eat. This is why we worked so hard to make products that are delicious and also good for you. They're all gluten-free, have no refined sugars, no sweeteners, and no additives. My personal favorites are the cheesy snacks, chocolates, and cacao hazelnut spread. We also have cookies, granolas, nut bars, nut butters, and protein powders, as well as many cool snacks to be released soon. At the moment, Naturally is only available in Europe. However, we're working to expand to other continents, so stay tuned. If you're in Spain, you can head over to our website, naturally.com, and it will take you to our online store. And if you're in Italy, Portugal, Germany, Poland, France, the Netherlands, or in Sweden, you can find them on Amazon. Search for Naturally. I will leave you all these links in the description anyway, so that you can find them. Thank you so much for listening, and stay tuned for the next episode.